Hi guys, welcome to Math Lessons with Miss Pine. In today's lesson, we are introducing functions grade 10. So before we get into details, we need to understand what are functions. When we talk about functions, we are talking about the relationship between two variables, the independent variables, which are our x values, and the dependent variable, which are our y values. So in simple terms, y values depend on x values. Functions, it's all about the relationship between x values and y values. So we have four basic functions that we are going to discuss in grade 10. The first function is the straight line function, which is defined as y is equal to x. Secondly, we have the parabolic function, which is defined as y is equal to x squared. Thirdly, we have the hyperbolic function, which is defined as y is equal to 1 divided by x. And lastly, we have the exponential function, which is defined as y is equal to b to the exponent x. These are our four basic functions that we are going to discuss about in grade 10. Now, one thing that I need us to understand before we continue with the lesson is that we have different ways of labeling a function, any function. Let's take, for example, the parabolic function. Here I've written that the parabolic function is defined as y is equals to x squared. But we can label this function in different ways. We can choose to label it as f of x is equals to x squared. We are going to see this a lot in your question papers, in your study materials. Now, don't get confused, please. F of x simply means the function of f with respect to x. And this f of x, it is the same as y. We treat it the same way as we treat y. Or we can use g of x is equals to x squared. This is just another way of labeling the function. Or h of x is equals to x squared. We can use any alphabet. But what I want us to understand is that this f of x, g of x, h of x, they are all the same as y. Okay, now guys, we are going to discuss those four functions individually. So today we are focusing only on the straight line function. We are discussing everything that has to do with a straight line. Now remember, we defined a straight line as y is equals to x. Now we are going to draw this function using the table method. We are going to find the value of y using the table method. Now this function is just straightforward. It tells us that y is equals to the values of x. The values of y are equal to the values of x. Now, when x is negative 3, y is also negative 3. When x is negative 2, y is also negative 2. When x is equal to negative 1, y is also equal to negative 1. When x is equal to 0, y is also 0. When x is 1, y is also 1. When x is 2, y is also 2. When x is 3, y is also 3. Remember the definition of a function? The relationship between x and y, independent and dependent variables. We say that y depend on the x values. This is exactly what we have been doing here. Now we are going to use this table to sketch the function of y is equals to x. Now let us sketch our graph. We are going to sketch our straight line graph on a Cartesian plane, which consists of a horizontal line, which is known as the x-axis, and a vertical line, which is known as the y-axis. This is a Cartesian plane. Now we have to label our Cartesian plane. Where the y-axis and x-axis meet this point, it is the origin, where x is equals to 0 and y is also equals to 0. Now, continuing to label the Cartesian plane, from 0 going to our right hand side, there we have the positive x values. We have the positive x values. So we have 1, 2, 3, 4, continuing up until positive infinity. This side we have the negative x values. Negative 1, negative 2, negative 3, negative 4. And then from 0 going upwards, we have the positive y values. From 0 going downwards, we have the negative y values. This is our Cartesian plane. When x is negative 3, y is also negative 3. Is our first point. When x is negative 2, y is also negative 2. When x is negative 1, y is also negative 1. When x is 0, y is 0. So it is here at the origin. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is also 3. We're going to draw a neat straight line using a ruler. This is our straight line graph. We have to use a ruler to draw a nice, neat straight line graph. And for you to get the accurate straight line graph, please make sure that the spacing in between your labels, in between your labeling, are the same. The spaces in between the labeling must be the same, and then you will get an accurate straight line graph. Now, I like to call this straight line graph the mother graph of straight line graphs. The mother graph of straight line graphs. Now, we are also going to look at instances where the mother graph, this straight line graph y is equal to x, can go up, it can also go down, it can also go left and right, and it is affected by other variables. So we are going to look at how are those variables making the mother graph go up and down. Remember that we defined a straight line graph by y is equals to x. That was the mother graph. Now we are going to look at how does the mother graph go up and down, left and right. So now we are writing the straight line graph in the form of y is equals to mx plus c. Let us look at how m and c affects the mother graph. M represents the gradient of the line, the slope of the line. Now when the gradient is greater than 0, that is when the gradient is positive, the line increases from left to right. When the gradient is positive, the graph increases from left to right. Let us try to demonstrate that. If we have a Cartesian plane here, and we have a graph, a straight line graph. This straight line graph, the gradient of the straight line graph is positive because the graph increases. Remember, when we increase, we are going upwards. So it increases from left to right, from the left hand side of the Cartesian plane to the right hand side of the Cartesian plane. Correct. Now, when m is less than 0, that is when m is negative, the graph increases from right to left. The graph will increase from right to left. Demonstrating this one, on the Cartesian plane means our graph will be like this. If you have a line that goes that way, it means the gradient is negative. The graph, the line increases from the right side of the Cartesian plane to the left hand side of the Cartesian plane. That is the effect of the value of m. That is the effect of the value of M. That is how M affects the mother graph. Now let us look at how C affects the mother graph. C gives us the value where the graph cuts the y-axis. Gives us the value where the graph cuts the y-axis. So in simple terms, we call C the the y-intercept. C, it is known as the y-intercept. Y-intercept is the point where the graph cuts the y-axis. So looking at this point here, where the graph cuts the y-axis, that point is the y-intercept. That will basically be the value of C. So C affects the mother graph by vertical shift. So if C is greater than 0, if C is positive, the graph will go vertically upwards. It will go vertically upwards. And if C is less than 0, if C is negative, the graph will go vertically downwards. The graph will go vertically downwards. Meaning that if we have a negative 2 here, the graph will go 2 units downwards. If we have a positive 2, the graph will go 2 units upwards. Okay, now let us discuss intercepts. We have the x-intercept and we have the y-intercept, which is given by the value of C. So the x-intercept is a point where the graph cuts the x-axis. It's a point where the graph cuts the x-axis. So the graph cuts the x-axis, the graph of the line. Yes. And then at that point, y is equals to 0. Any point on the x-axis, y is equals to 0. And then we also have the y-intercept, which is given by the value of C on a straight line. The y-intercept is a point where the graph cuts the y-axis. And on that line, on that point, x is equals to 0. Any point on the y-axis, x is equals to 0. Guys, please forgive me, it's load shedding.